All right, everyone, welcome to Orlando Python. For this month, we're going to talk about a library called Marimo, which has been, to my knowledge, in the works as a from the ground up replacement for Jupyter notebooks that was designed specifically for a team of scientists. An engineer was developing it with them hand in hand. And it's what Jupyter or like well IPython notebooks, what they were originally called, which is why the Jupyter notebooks still have that dot IPYNB uh, extension. So this is what Jupyter would look like if it had over a decade of learnings put into it. I will say there are a couple of very fundamental changes compared to how we traditionally use notebooks. I'm not going to say that they are better or worse depending from a user flow. There's definitely positives for some of them, but they can take a little bit to get used to, and I'll go into that. Uh, so Marimo, and we were just talking about this before the talk, but unlike things like Google Colab, Marimo is designed to be like Jupyter notebooks, where they are running locally on your machine. Yeah, you can run and host them elsewhere. You can save them, but this is not something that needs to run off of your computer, much like Collab. This is something that you can run locally. You can have this running on a Raspberry Pi on your home network and connect to it like that. You can have one in the cloud all you want, but this is really more Jupyter, less Colab. The If I had to describe the three main differences between Marimo, and Jupyter. The three biggest improvements are it is designed from the ground up to keep data consistency. So there's no running cells out of order. And in fact, because it enforces its own cell order, you can move your cells out of order. That sounds really weird when I say it like that, and it's still going. And honestly, that's the hardest thing to wrap your brain around once you start playing with Marimo compared to Jupyter. But it will completely eliminate the I'm done with everything in my notebook. Let me clear all the outputs and run from scratch. You will never need to do that again with Marimo. The second is that it is designed from the ground up to build web applications, interactive applications. We, anyone who's used Jupyter Notebooks long enough know that the end result is not often just, oh, I'm done with my notebook file. If I'm sharing to a technical person, sure, I'll share the notebook. But if I am creating this for a non-technical person, I'm generating a report, the output is going to be more often than not HTML or a PDF file. Uh, this is so built into Marimo compared to Jupyter Notebooks that you can at a glance switch between edit mode and app view mode to see what it looks like. And that's something I will definitely be showing off. The third difference is all of the tools that you expect from something like Jupyter Hub compared to, say, Jupyter Notebook are here in force. There is an entire management suite, dependency management. There's no like a shebang installs that you need to do inside of your notebook code. It's available in the source, but you won't actually have to have any of that in your notebook data itself. And if I attach one more fourth thing to this, is that IPython notebooks, the core data structure of of a Jupyter notebook is a giant JSON blob. And whenever you go to do a commit history with IPython notebooks, it's an absolute nightmare. Uh, just because of all the metadata changes and run history, everything that is in that giant JSON blob. However, Marimo is ditches JSON entirely and uses native Python files themselves. So whenever you're writing code, you're markdown, creating cells, seeing the output, it's all put into a Python file, which does two major things. A, it really cleans up your GitHub history. Because if you make a one line change in your notebook, there is a one line change in the Python file, which means there's a one line change in that Git commit. As opposed to in Jupyter Notebook, you change one line and you reran it. Now you have hundreds, maybe thousands of single line updates with all of that management and metadata in the JSON blob. The other thing with it being a Python file is much like using no, not paper call, paper mill with Jupyter Notebooks, where you could take Jupyter Notebooks and turn them into running production-ish code. Because your Marimo notebooks are a Python file, you can run them as a Python file. You can import, you can run them as code. It's pretty nifty. So I hope I've sold it a little bit as to why you might be interested in using this. But honestly, the best way that I can show you, as we do with everything that we do at at these tech talks, is actually diving into some code. I'm not gonna go in depth on what they have on the website. It's marimo.io. Feel free to look and follow along. But you can see, just like Jupyter Notebook, this is a pip install. And the second line here is exactly what we're going to type into the command line, which I know you can't see right now, but this is the only thing I'm typing into the command line, and it should pop up just like Jupyter in our browser here. So this is their built into their command line tutorial introduction to what Marimo does. And you can see both the input and the output is driven on a cell by cell basis. We can go ahead and add and delete cells. Everything in here is designed to be interactive. So Marimo is a reactive Python notebook. So here we created a slider, but we haven't done anything with it yet. Down here, we actually have a markdown cell that uses the values in this slider. Uh, even though this is a markdown cell, they effectively treat them like F strings in Python. So you can use your regular old curly braces and you get access to all of the Python goodness to put inside of here. So I can move this bar and have live instant updates, just like you have with IPython widgets uh, over on the Jupyter side of things. You can also, on a cell-by-cell basis, disable automatic execution. You can also do that all the way down here on cell change and on startup, go from auto run to lazy modes as well. Now, the whole thing with reactive execution is, and this is the hardest part that you're going to have to get used to, is the fact that order is not based on the cell order. What they do, rather than you can build up your file going cell by cell by cell, just like Jupyter. The main benefit and also pitfall of Jupyter Notebooks is that you can run cells over and over and over again. And all it's doing is updating that hidden behind the scenes runtime, not affecting anything on the front end. What Marimo does is it builds up a dependency graph from all of the different cells. So anything that is considered a global variable, so changed, this slider here, Marimo itself, import Marimo as mo. Every root, like every variable that you declare in a cell that is at this level. So if I do like def whatever and put stuff in here, this would be a global variable, but this is not. So anything that is a global variable is now part of this dependency graph. And the reason why this works here is because this cell uses the value of slider and uses the slider itself and it uses the value of the slider. So even though we declared it up here, this cell is updating this value of slider. So every time that this value is updated, this cell down here will be re-rendered. It sounds simple enough, but there are some very interesting consequences because of this. The first is you cannot, once a global variable is set, you cannot reassign to it. So if I add another cell down here, and maybe I want to change a different slider. So UI slider like 0 and 1. This is going to give me an error because this cell redefines the global variables found in other cells. Trying to redefine variables in multiple cells is not allowed. It breaks this dependency tree. If I wanted to change the value of this, I have to do it in the original, or I could use it elsewhere, but I have to delete the reference in the original. At that point, I can rerun, and because this cell is a dependency of this one, it automatically reran once I updated this. If you are diligent about treating things like I set this once and I don't update the value, like I set x equals 42 and then I use x, and then another cell I do x equals 3 and then I use x. If you're not doing that, then you may not ever see this problem. But this is something that is very different from your run-of-the-mill Python, where in Python, you can have my value equals true, my value equals 42, my value equals my value if you want. You can update, you can change the type, you can change the value anytime. Because they're doing this object reference hierarchy in the background, that's something you're going to have to watch out for. So you can mutate the data, you have to mutate the original. Or you use inputs like this slider, because this slider, if you worked with Python long enough, you know that everything in Python is an object. It's a class in one way or another. This slider here, even though we're changing the value, we're not actually changing the fact that slider is a object called slider. We're changing the slider dot value on it, which means that this is perfectly okay, even though it's being changed in another cell and all of that. So I'm sure I will get more questions, and I actually do have a tip for how to work with that later on. So further down, we're looking at UI elements. I can open up an entire separate notebook from their tutorial showing off all the different things, but you can have various combinations of UI elements that can combine in different ways. So here they're showing off using a drop down and a slider. And you can see in here that uh, they're using a they're using a tuple representation to get this in here. If I rerun this, there is one noticeable difference. Actually, I don't know if this is. I think this is different than Jupyter. It may not be. There's only supposed to be one output for each cell. Technically, doing icon and repetitions is two, so it's only going to show the second here. Technically, this is one because we return a tuple basically. Uh, the other way that we could do that, and it was shown off up here. No, it'll be shown off. We'll show it off elsewhere. We can embed any number of these UI elements into a Python-based markdown, and it will work just fine. So talking about Marimo is just Python. Oh, right. I mentioned this. So we have, and this is a tutorial, but it is still an application. We have interactable elements that do things. And if you look down on this bottom right corner here, we have a couple of things. We have things like quick command palettes. This is a an editor, text editor after all. It's going to have its own shortcuts. We have a way to manually save. And since this is a tutorial, I would have to come up with something different. Uh, there's also stop all cells, run all cells, yada yada. And there's this here. We have toggle app view. So right now, this is edit. This is what you normally associate with a notebook. We're looking at different cells, and the cells can have output. When we switch to app view, this is what our notebook looks like if we were to go deploy this on Hugging Face, for example. All of the code cells are gone, but the output that they generate is still there, including things like these drop downs, these call outs, all of our markdown. Everything that is considered an output of your cell is still here. And if we want to just pull it back, we go back to toggle app view, and we are back. Uh, so let's see, Marimo command line tool, rather than the equivalent of doing Jupyter space notebook to open up your notebook editor window, you're going to do Marimo edit. You can also run them as apps by doing Marimo run with the app name, and that automatically launches it as a web page version like this, which makes it easier for sharing. Let's see. What else in this one? Yeah. And then, oh, and because they know that people are coming from Jupyter Notebooks, they have a handy dandy conversion tool, Marimo Convert, and then output it. Then this just pipes sends the output of this command into a file called yourapp.py. You now have a Marimo notebook. Uh, because because this is just built into the pip install, I would highly recommend going through their tutorials. There are a couple of other things that I can go over. For example, the first one, because they know this is going to be a huge headache for people, is the data flow. Data flow is them trying to tell you how this dependency graph works. UI is a walkthrough of all the different, well, most of the UI elements that are here. all the different ways that you can use Markdown. Oh, and by the way, it also supports LaTeX natively if you find yourself writing a lot of mathematical equations. Plots showing all the different ways that you can use. Matplotlib is what they have in this one, um, with some links out to the other libraries showing how you can work with those. Oh, by the way, much like with Jupyter Notebook with some of its extensions, SQL is supported natively out of the box to have SQL specific cells in your notebook. Their demo here works with, I actually don't remember. We could open up the notebook and, and see, but it's designed to work with one locally, but you can connect it to any remote one as well. You can use layout to structure your notebook. It's similar to, well, almost pretty much any modern code-based UI. Think of it like Swift UI or Bootstrap. Let's see, file format, markdown format, and specific things called out for people coming in from Jupyter. Uh, let's see. I think, let's see, do you need to use the connection string to connect to the SQL database? You would in one way or another. You have to set up a connector somewhere. Let's jump into the SQL notebook. So I'm going to stop the connection. So I stopped the command line, so we now have a broken notebook on there. But I'm just going to do marimo tutorial SQL. In the command line, we'll jump right back over here. Uh, Here is a little intro into why Marimo is more like Jupyter Hub than just regular Jupyter Notebook. You can see, hey, in order to run this Marimo notebook, I am missing a couple of packages in my environment, and it can go ahead and do that for me. So, oh, DuckDB is what they were using for their local. But I need DuckDB, pandas, polars, and SQL or SQL I don't know. I'm thinking like ggplot or something. We can have it automatically install those for us. What you can't see off screen right now is in the same command line that I have open that's running this notebook. It is using pip to install those dependencies in the background. And since we're over here, it's not the pack here, packages, we can see everything that is currently in our environment, as well as upgrading or removing various things we can use here to search. This, I don't actually, oh, I think I'm running this in my, yeah, I am. I'm running this in my root directory for some reason. So that pulled up my file, the root file browser there. These are all the global variables that it is tracking. So if you don't know where, let's say, Polar's PL is, well, it's in cell 8, so we can automatically go down to there. We have data sources here, so SQL with DuckDB, and Python data sources with a data frame. So anything that is installed in here, or any data frames or any SQL databases that we want to pull in addition to being able to do things like df head, df tail, whatever else inside of here, we also can get some of that. And it apparently uses Altair to do its chart rendering for you as well. So there are some very nifty tools you can do, including, if you really want to, ChatGPT integration over here. Let's see, view live docs as you talk. You can have notebook logs attached to it. There's stack tracing as well. You can save snippets, and they have some of their own as well. So here's a snippet to load a .env file, so on, so on. Secrets attached to it, so on. So you can see how this is a bit more Jupyter Lab when I show you all of these. And again, this is all running locally on my machine. This is not Colab. Uh, Let me go ahead and close this. We can get right back into the notebook here. So all done with this. Oh, by the way, you can see that some of these cells are a little grayed out. I can choose to unhide the code here so we can see why this is actually generated. If has DuckDB installed, yada, yada, yada. So this is installed, otherwise it would put some other kind of warning not installed, DuckDB is not installed. So SQL cells, just like any other cells, we can do plus down here, and we have a type where we have as an SQL cell, a markdown cell. Those are the defaults. I have seen other types as well, but we can click that and we now can do, select star from, et cetera, et cetera, et cetera. I don't, let's see, marimo still just Python, even if we're using SQL, yada, yada. So that this is basically what we are generating. So let's see, select star from, my table limit, and then we can still use this, and we have all of our regular uh, auto completion because it's like any good text editor. So even though we're in an SQL cell, it's just like Markdown. You put those curly braces in here, and it's an F string, just like you see in the Python example here. So I'm going to go ahead and get rid of that. I am curious. We try to work. Okay. We're missing pi arrow. We'll go ahead and take care of that. And done. So we can now run this. It did run. It still needs it.
Well, in Jupyter Notebook, you have to just establish connection string first with the SQL like a database. And when you can just run these queries to extract data. But I'm not really sure how it works here because like in Jupyter Notebook, it's sequential and you saying it's not. So because what I normally do, I just connect this like with connection string. Like there's like of course
Mhm.
libraries you have to import, blah blah blah. Like just like and just like define your connection string and just choose the name of database and stuff like embed password and everything because like our data encrypted with the passwords. And when just like it's wrapped in the Python code, like the SQL. I'm not sure how it works here, but I'm just saying it probably might have like a similar kind of like a logic. So you
So,
just, yeah, you're calling out with Python code, but you just embed this SQL query inside.
so the main, I can tell you that what it's doing right now is it's using DuckDB, which is a data it's similar to SQLite. It's a database that lives in your current working directory.
Mm, okay.
So it's not connecting to anything external, at least in this template here. And I'm sure we can look in the docs to see how to. Uh, they should have they should have something there to have it connect to a uh, something like Postgres or MySQL that
Mhm.
is not something that lives locally like DuckDB. Uh, so. Querying files, databases, and APIs. Dun, 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 dun. So They're just putting in the connection string here as a string. Select star from, well, here's a file in S3, like a Parquet file. DuckDB extensions, examples on GitHub. Here, connect to Postgres. Uh, I was going to get to this, but I will gladly show this off now. This is what I mentioned that Python, Marimo notebooks are stored as Python natively instead of uh, JSON blobs. This is what your Marimo notebook looks like under the hood. It is indeed just a Python file. It includes all of its metadata as a doc string well, it's not even, well, it's kind of a doc string. It's not really a doc string in this format. It's just in a code comment. But each one of those cells is just app at app.cell. And here, this one is the markdown. Here's one, the code is automatically hidden. So here you can see they're using a URL to connect to something, a remote SQLite file for them to pull in. Got to have something down here. They have a cell that is pulling in a password from the environment. Oh, and not that you would ever really need to look at this under the hood, but this is what it looks like for Marimo to pass these dependencies to the cells. So your code in here only actually is given the variables, those global variables that it will actually use. You don't need to worry about that when you're using the Jupyter Notebook, but when it's saved, and if you were to run this as code, just running it as code, you can be sure that all this, like, no cell will be given more than it needs to, which is just good Python. So they're using, yeah, they're generating SQL here. So attach database name, Postgres. Uh, I'm not familiar with this syntax. It's not like a URI, but they're setting that up and then showing all tables as its output. Presumably at that point, anything else that is dependent on this, yeah, we can do select star from DB public test table, which would be in here in theory. Uh, yeah, schema public. So there are ways to do it. It's I haven't done that to prep for this talk, and they're just using a local database for their well, understandably for their tutorial. So, so for SQL, you can have SQL queries embedded, and your Python code, it's probably not going to render too well because something is still going a little squirrely in here. But you can have Python code talking to your SQL cells just like you do in Jupyter. Yeah, it's not so great here. You can, just like we saw earlier, you can see that we're doing the curly brace syntax, and then this invariably down here. See, we have the selecting a charting library, and then this is render function. Trying to see where, yeah, using matplotlib, altair, plotly. Ah, okay. So result is they have put the out yeah, here we go. Select star from data from DF from data frame, by the way. So this is SQL pulling in from a data frame. starts with token, and then output variable equals result. So this line down here, which is part of the cell, by the way, I'm just going to hide this out. No, it's still going to bug me. You can assign the results of your SQL to a variable name that we can see later on is used by these to get result count and result data down from here. Let's see. Uh, we're about 30 minutes in. Uh, I did create a or well, I upgraded a notebook that I had previously given right before the pandemic, actually. And I can show you what that looks like. So this was a very bare bones notebook that I created a while back, where we were using NumPy to generate audio wave data. So just know that we have oh, this was the eventual output. We're using this interact and this IPython widget audio here in order to make this work. IPy and IPython.displayIPD. Uh, so we would create a function that would be given the following sliders, and then it generates the output here, which was to print some audio data, generate a plot, and to finally create the resulting audio widget that we'd be able to use. And so what that ends up looking like is this. Uh, it's a little squirrely because this is one very large cell, and you can see I can scroll down here, but if I want to change something, it kind of freaks out on me a little bit, but it does work. Uh, I'm hopefully the audio comes across. Not that it's terribly great just because it is a pure tone. I can click this and it generates a pure tone of 200 hertz. If I increase the source hertz, it creates a more tightly dense waveform, sinusoidal waveform in here, which our ears interpret as a higher pitched sound. I can also just increase the size of the array itself, which in this case just means a longer audio. So 3.8 seconds. There's also, because I was just being very silly, adding some wobble into this. So I can increase this wobble value, which adds a modulator into it. And so you can see now we have two two different sine waves perpetuating through it, and that sounds like this. I've created a chord basically using NumPy. So I gave this back in 2019, maybe even like January of 2020, somewhere in there. And I thought this would be great. This is using that I basically used Jupyter Notebook to create a little interactive application. This sounds like a perfect way to a perfect use case to use Marimo. So I found I found that they have a similar audio UI element here. You can give it either a link, a path on your local machine. You can give it a NumPy array, an ND array, or you can give it just the raw bytes, audio bytes, and it will play it. So, by the way, when you do Marimo edit, this is what pops up. So workspace, recent notebooks, quick links for documentation, and quick links to all the tutorials. Uh, it's they've done a really good job with this. So this is what my updated Marimo notebook looks like. So you can see here, I've created Marimo UI sliders for each of those. Uh, and I have generated this first cell here by using those in a marked code-based markdown element. I could do this same thing by doing include cell below. I'm going to switch it to markdown here. I can copy this. Da-da-da. Well, that's what it should be. Oh, raw string versus F string. Rerun. There we go. Uh, if you're not familiar with Python's raw string and F string, uh, if you leave neither of these checked, it's just a regular string in Python. It's going to do things like character escapes, etc. If you've done any amount of SQL or regex in Python, you're going to be familiar with the raw string and R string, which means it's not going to do any interpolation. It's just going to give you the text as is right back to you. And I'd say most most people now are familiar with F strings, which does all of that lovely code formatting for us using these curly braces. So if I rerun this, there's now no output here because all we've done is use this to set this up. And instead, I've given that to a markdown cell, which we could move to the top of the file because visual order doesn't matter. And I'll show that off by just showing you that my imports are down here, as well as a unchanging global variable is down here. I also have that make audio function down here that it doesn't need to fit in here. All I need is for it to be available to this cell to create the audio data. And in fact, I could even move this down, but I think for clarity purposes when reading this, even if you don't need to know what make audio does, it's nice to know that we are generating audio with the values of the sliders. Okay, so functionally equivalent. Here, after we generate the audio data using the values of those sliders with this function, I'm just printing the audio data, which it's going to do its best, but you can see is and based on the graph, this is just uh, sinusoidal points along a graph in a very large, actually, 22,050 length ND array. And this is just graphing out the first 2,000 points along that graph. So not this is technically a point graph, it's not a line graph. And then finally, we take the audio data and we do have to give it a sample rate when we're just passing in raw data, like the ND array, so it knows how to generate it. But then we have our audio data. And more importantly, this is in Marimo. With a click of a button, I have now turned this into what looks like a web application because it is. And because these are all in different cells, I can instantly just drag stuff around here. There's none of that wonkiness that we saw before of it having to redo all of these different cells. And you can see it is just instantaneous. So let's say the source shirts there. Both of these do have to have some value in order to see it. Add some more wobble. So how different they are. Get these closer together. I'll just make the duration a little shorter. And so we now have a web app that we could deploy to Hugging Face or to an internal server or share with a colleague or share with a boss. That is, with at a click of a button, you can go in and update whatever you need to. And with another click of the button, hey, I made that change. Come play with it.
Yeah, I'm kind of confused. How do you share it if it's runs locally on your machine?
So there's two things. Uh, because because you're sharing a Python file, if the output, like if you're writing this to to do a task, then you can just share the Python file. They would need to have Marimo on their machine if it's doing local
Oh, mm,
things. But because this also renders to HTML, it is possible to export this
mhm,
to raw HTML, and then you can share and host that anywhere.
mm.
You can even backport this to IPython Notebook, to Jupyter Notebook if you really wanted to. Even things like app titles, display, columns, full screen, et cetera, et cetera.
Okay, now a question. If you export it in HTML format and share it with someone, will it be still interactive like your application or
Yes. So in their documentation here, so we have exporting to other formats that we like we saw there. There's an entire publish to the web, so embedding it, code snippets, GitHub Pages, Cloudflare, creating an online playground, even self-hosted WASM. There's deployment sections for Hugging Face, Docker. How do you do authentication when you when you do it? What about Nginx if you're trying to do that? Also, WebAssembly notebooks, which is what we were seeing just now with the never-ending circle. Uh, so in theory, this should be easier to share with your coworkers, with your boss than notebooks. Uh, like any new tool, it will take some time getting used to and learning where everything goes. But I hope that you can see when looking at the applications just how well, interactive, how cool, how it should help you from save you from some headaches when you are trying to figure out how to reproduce the code that you've already written because you just didn't do it in the same order as it exists in the notebook. That was always a problem for me. Uh, and being able to run it as just straight code. So if the intention was to say rather than create this lovely little web application, if I wanted it to, I'm creating a notebook and maybe I'm pulling in data I want to visualize, I want to allow it to, I want to allow my boss to play with the outputs, to dial in whatever report they wanted to generate. And if the final output of your notebook is and generate the report, well, your boss can do that. Say, hey, I like these defaults. Go ahead and set them as the default. And now, without having to extract the code from your notebook to generate a cron job or a Lambda function, you can just say, hey, just here's the Python code. Just run this. Just deploy your actual functional code. Jupyter has something like that called Paper Mill. I'm sure there are other ones that came along. That's just the one that comes to mind. So I highly recommend taking a look at it. I think you will be surprised at what 10 plus years of community-based improvements and learnings will do to something as core as a scientific text editor and notebook generator. Uh, I'll take any more questions as we're wrapping up the talk and the meeting. If there's anything else that people want to see,
Oh, thank you for showing us this. That's pretty cool. I want to play with that. And I just don't really like the that this tool is not sequential because that's not what I get used to. You know what I mean? And I like having like a like a output per like as a data scientist, it's just easier for me to read like a data cell by cell because but here I guess it just has to do with like like you said like getting used to you probably can just
Mhm.
embed several print statements and just generate everything like at the same time. uh, Not super convenient, but could be done because you would do the same in like VS Code. So it's just kind of like a separate VS Code files pretty much that has the same like logic, right? Like,
Mm. And I completely forgot that tip I was going to say. Just because these cells can be moved and you can drag them wherever,
mm-hmm,
you can still just leave them in order. So you can do import marimo as mo.
mm,
Oh, oh yeah, it's okay. Python. And that can stay at the top of my file forever. Equals mo.ui dot slider between 0 and 10 and just do slider. Uh, run everything. Oh, not like that. Or maybe I'm not sure why it doesn't like this right now.
well, if you said it's sequential, you probably will have to enter like import at the same time as you assign this variable. That would be my guess. But...
I is this not, I guess this is not a Python cell.
Oh,
Yeah, toggle as Python.
mm-hmm,
Yeah, okay. Oh yeah, so these are quick links for introducing a new Python Markdown or SQL cell at the bottom. So I want to add a new Python and a new Markdown and new SQL. Uh, so
okay, it
just
works.
because you can move things in a different order, doesn't mean that you have to. You could leave this as you want. Uh, it all the code gets hidden when you look at the
Mm-hmm.
app view, no matter what, or when you export as an HTML page. Uh, However, they do allow that functionality because even if you want to just come back in here, you don't always need to see. If you're comfortable with it, you can drag the cell around to the bottom, it'll still work. And it's my recommendation is to build it out in the order that you are comfortable with, just like you would in a traditional notebook or a Python file where everything is
Mm-hmm.
sequential, like truly sequential in a Python file. And once you
Mm-hmm.
are just done, you're not going to touch it, except for playing with the fun things on the top. You can move all the extraneous stuff down to the bottom so that when
Mm-hmm.
you do want to come back in and make tweaks, the cells that are on the top or the ones that are important for display order are the only things that are on the top and everything get moved down to the bottom.
Mm. So you can still import libraries as a separate cell, right? And it will affect like
Hmm.
the. Oh, okay. Oh, that's good to know.
Yep. And it will one there's kind of an interesting thing here. You traditionally we put import uh, matplotlib dot I don't even remember things anymore. Uh,
Yeah, AI does or that too. I
yeah,
don't
numpy
remember.
as np. Uh, and when this cell updates, it will automatically re-render here just because nothing here is using np. But the cell with Mo got updated, so it re-renders this cell up here. If you want to let's say you have a really expensive computation. Thank you, import matplotlib.pyplot is what I was forgetting.
Yeah,
Uh,
no worries. I just like honestly with AI, like most codes are generated with AI, and I'm just forgetting such a simple syntax these days. Unlike
mhm.
so I can totally relate, honestly, trust me.
Uh, let's say I import sklearn. I definitely don't have it installed, but
Mhm.
yeah, scikit-learn, sklearn. Um, this is clearly when if I had a bunch of things in here, I don't want all of my machine learning library based cells to re-render every time that I import a new library in the same cell. So if you have a really long running tree like that, when these are set to auto update, there's two things you can do. You can uh, put this import and any of those dependencies in their own cell so that you can still do more things in here and not have it trigger updates. You can also toggle these on the bottom to do on startup, on cell change to disable the auto runs. And then I believe there's also a thing in open cell actions here. Yeah, we can go on a cell by cell basis and disable the automatic reactive execution. So in addition to everything that I've talked about, there's so many more tools here at your disposal that you can learn about and play with. Yeah. Just everything on the sidebar. Uh, I don't have it connected, but this has an integrated AI assistant. There's this whole generate with AI that would be enabled if I had that setting enabled.
Yeah, I wonder what model we use for AI. Like,
I was reading edit AI settings. Oh, okay. So OpenAI,
oh, AI.
Anthropic, or Gemini. You can
Oh,
also even connect it to Bedrock if you wanted to.
oh, so you have to connect with API key?
Yes.
Oh.
However, it kind of looks like, well, edit MP to Mira's AI assistant. Yeah. So, oh, you can also do GitHub Pilot, GitHub Codium. Custom one, I think, is going to be the more interesting ones because it gives you a base URL. You could have a code assistant running as part of Olama on your local machine, and now all of this is done locally.
Oh, that's cool, actually.
uh, Labs optional dependencies, which we saw earlier for things like SQL cells, Altair for the sidebar. There's just so much that you can play with. I think I'm actually curious. I think it's about 5 years old, but we could very easily go to uh, Marimo and have it link over to the GitHub profile here. Their oldest file here. Well, third party licenses is 2 years ago. The license itself is 2 years ago. Yeah, so this is a very new product, but you can see just how fully baked it is for being so new. If you're more of an audio person like I am, for a podcast, I would take a look at Talk Python to me. And I think also the Real Python podcast both did interviews with the creator of Marimo, and he can give more of the historical uh, anecdotes that I couldn't remember while diving into it.